Okay, looking at substitution today. Substitution has a lot of similarities to elimination. The part that's different is how we get to equations 4 and 5. Okay, once we get to equations 4 and 5, the rest of it is the same. Okay. Some things aren't changing in that first thing I'm going to do is I'm going to number these equations, 1, 2, and 3. And again, that's for an organizational purposes and just being able to refer to them by some numbers. If you think back to substitution, when we had just 2 equations, do you remember what the first step was I always had you do? Okay, pick one equation and solve it for x or y, right? Isolate a variable. Same drill here, except now it's pick one equation and solve it for either x, y, or z. So that's going to be our first step, and I'm going to write a note here about it. Solve an equation for x, y, or z. As you guys look at this problem, what do you see? Do you see an equation you want to solve for either x, y, or z? What do you see?
Equation 2, you can subtract the 5y over.
Okay.
Okay.
So we tend to agree. Equation 2. And if we use equation 2, the idea is we can get the x by itself. And you girls picked the x because it's a 1x already, yes? It's easier if you can get the x by itself. Okay? Because it's a 1x. So, let me write down my equation 2 here. It is x plus 5y equals 9 to begin with. And yes, as we said, if we subtract the 5y over, this now becomes x equals, you can either write it as 9 minus 5y, or you can change it around and make it negative 5y plus 9. Okay. I don't renumber this equation, I just usually call it the new equation 2. Okay. Now, think back to substitution. Once you had an equation solved for x or y, what did you do with that? You plugged it back into the other equation. In this case, once I have equation 2 solved for it, or one of the equations solved for it, you're not going to plug it into just one other equation, you're going to have to plug it into both other equations. So the idea is here, we'll take equation 2, we'll plug it into equation 1, we'll clean it up, and that will create an equation that we'll call equation 4. Then we'll repeat the process, take equation 2 again, this time plug it into 3, and clean that up, and that'll create an equation that we'll call 5. And then once you get to the point of having 4 and 5, the process is the same. Okay? So some of the equations you'll see in homework, actually the first step is already done, where it's already the x equals and y equals, so it's just a matter of going from there. Okay. So equation 1, let me write it down here. It's 2x plus 3y minus 2z equals negative 1. Every place I see in x, we're going to replace it with negative 5y plus 9. So it's 2x, which means I'm going to do 2 times negative 5y plus 9, still plus 3y, still minus 2z, still equals negative 1. Do your equation solving steps. What do we need to do now? Good. Distribute that too. 2 times negative 5y is negative 10y, 2 times 9, plus 18, still plus 3y, still minus 2z, equals negative 1. What's next?
You can either move over the 18 or you can combine like terms.
Okay, both steps need to be done. Let's go ahead and combine like terms first. In that negative 10y goes with 3y. Negative 10y plus 3y is negative 7y. I still have my plus 18. I still have my minus 2z equaling negative 1. Leave the y and z and move the plus 18. So if it's a plus 18, subtract the 18. So now I have negative 7y minus 2z equals negative 19. I'm going to call this equation equation 4. Right there, I took 2 and plugged it into 1. Now I'm going to take 2 and plug it into 3. So let me write my 3 out. 4z minus 5x equals 4. Every place I see an x, I'm plugging in negative 5y plus 9. So 4z minus 5x, so minus 5 times negative 5y plus 9 equals 4. Now we need to distribute. So carry down the 4z. Minus 5 times minus 5y is going to be plus 25y. Minus 5 times 9, minus 45, equals 4. I've got my z and y on the left. To move my minus 45, I'm going to add 45. 4z plus 25y equals 49 when you add the 4 and 45. You can call this equation 5, or what do you notice is slightly different about equations 4 and 5? And it will kind of matter in the next step. Equation 4 was y then z. How did this one end up the way I wrote it? Z then y. When I go to that next step and I have to line these equations up, I need them in order, yes? So if you, at some point, you're going to need to flip one of them. So if I go ahead and flip this one, I'm actually going to write it as 25y plus 4z equals 49. And that's what I'm going to call equation 5. Technically, if I call the equation 5 at the previous step, that's the same thing. But just stating, you need to watch out and make sure your variables are in the same order. Okay. I've got an equation 4 and an equation 5. From here on out, it's the same old process. So let me zoom out a little bit. Ooh, that's a lot. Let me write my equation 4 and 5. So equation 4 is negative 7y minus 2z equals negative 19. Equation 5 is 25y plus 4z equals 49. If this isn't a good substitution setup, I'd say, sure, let's go ahead and just substitute again, but it's not. What would you like to eliminate here and how? Z's are definitely a bit more friendly to eliminate on this one. I mean, we could do the y's, but you'd be multiplying by 25 and 7, which does not sound interesting to me. So if I multiply the top equation by 2. So that top equation becomes negative 14y minus 4z equals negative 38. My bottom equation stays as is, 25y plus 4z equals 49. My 4z and negative 4z are opposite sign, so I'm ready to add. Negative 14y plus 25y. 11y. Negative 4z plus 4z. Cancels. Carry down my equal sign. Negative 38 plus 49. 11. If 11y equals 11, divide by 11, and y equals 1. Huh? Good news is the next two steps are very minimal, but yeah. All that to get one variable, unfortunately. I mean, you're kind of seeing, this is the ugly side of elimination. Not all elimination you'll do will start out quite that big. Okay, you'll see some that will be easier than that today. Okay. Once I have y equals 1, what do you want to do with that? Okay. Traditionally, the answer is to plug it in, take it back and plug it in for 4 or 5. You also have other options in this case. We could also plug it into 2. You want to plug it in anywhere that there's an equation that has y and one other variable. Does it matter? Not really. Okay, I mean, it's plugging it in so you get your answers you need. I actually do like the idea of plugging into 2 if you guys want to go for that. Because, and especially, besides 2, could I use my newly solved 2? I could use the 2 that was x equals negative 5y plus 9 if you want. And that's even nicer, isn't it? So, x equals negative 5 times 1 plus 9. Negative 5 times 1 is negative 5, and negative 5 plus 9 is 4. Now I have y and x. Plug in some equation that has a z. Normally we say you go back to 1, 2, or 3 at this point, right? But actually you couldn't use 2 because it doesn't have a z. You can use 1 or 3, or you could even go back and use 4 or 5 because we haven't used those yet. Okay? I personally like 3. I don't know what you guys are using, but again, we're flexible here. 3 is 4z minus 5x equals 4. So 4z minus 5 times 4 equals 4. 4z minus 20 equals 4. Add the 20 over. 4z equals 24. Divide by 4, and z is 6. Did yours match mine? I mean, it definitely did if you followed me, but if you took a different direction, did it match me? How do we express our final answer?
And then order triple.
Ordered triple. What's my order here?
4, 1, 6.
Okay, 4, 1, 6. Don't forget that alphabetical order. Process-wise, it's similar. I don't know. I taught this one secondly because it's not, certain problems it works well, but overall it's probably not the go-to method. I get it. Questions on that one? Okay, let's try example 2 then. As you look down at example 2, what's the first thing I'm going to do?
Label them.
Yeah. I'm going to label my equations. 1, 2, 3. And then I'm going to pick an equation and solve it for x, y, or z. So isolate a variable. What sounds like the best plan here?
I like 1.
You like 1?
Yeah, solving for Z.
And solving for z.
Positive.
Okay. So it's a positive z. What are other options?
You could really do any of them.
Okay, really you could do any of them because 1 you can solve for z. 2 you could solve pretty well for
Z or X.
z or x. And 3 you could solve for x. And I agree, we can do any of them. Now, there's one part that I would say is a little bit easier. And I don't think it's 1.
So 3
Solve 3
for X.
for x. Why would solving 3 be a little bit easier than 1?
Because there's not a 1.
There's not 2 extra variables, there's only 1 extra variable. Okay, now, am I saying that it won't work the other way? No, not at all. Okay, I'm going to go, in this case, this type of situation, where there's only 1 extra variable, I'm probably going to go for that. Okay, however, they all work. Okay, so I'm going to pick 3 here, which is x plus 2z equals negative 8. And to get that x by itself, I am going to subtract 2z. And so now I have x is equal to negative 2z minus 8. And that is my new equation 3. What do I do with that equation 3? Plug it in, yes? So equation 1 is 2x minus y plus c equals negative 2. Every place I see an x, we're going to plug in 2 times x, which is negative 2z minus 8. Still I have a minus y and a plus c and equals negative 2. Clean up. First we need to distribute that 2. 2 times negative 2z, negative 4z. 2 times minus 8, minus 16. Still minus y, still plus z, still equals negative 2. Next step, I can combine like terms, clean up the z's. Negative 4z plus z is going to make it negative 3z. Still minus 16, still minus y, equals negative 2. I got a z, I got a y, I need to move the The minus 16. To move the minus 16, I want to add 16. So now I have negative 3z minus y equals 14. Okay. I'm okay with going ahead and calling this equation 4 if you want. The one thing to be aware of, notice it's in zy order. That's kind of backwards from what we usually do, isn't it? But honestly, it'll work just fine if the next one is also in zy order. If it's not in zy order, we're going to have to flip one of them. Or you can go ahead and flip this now. So I am fine with calling this equation 4 for the moment. If you'd rather go ahead and flip it, it's negative y minus 3z equals 14. Excuse me. So that's equation 4. How do I get equation 5? Okay. This time 3 is going into 2. So let me write out my 2. X plus 3y minus z equals 10. Every place I see an x. So since it starts off with x, negative 2z minus 8 plus 3y minus z equals 10. Negative 2z minus z is going to become negative 3z, still minus 8, still plus 3y, still equals 10. So now I want to keep the 3z and the minus 3z and the 3y, and I'm going to move the 8. So if it's minus 8, let's add 8. So now, negative 3z plus 3y equals 18. What do you notice? Equation 4 was z then y, and equation 5 happened to come out z then y. So I can call this equation 5. Unless I flip to the other one, then I have to flip this one. And then it would have been 3y minus 3z equals 18 if you happen to do that. And so now we put together equations 4 and 5. So equation 4, negative 3z minus y equals 14. Equation 5, negative 3z plus 3y equals 18. What are you guys thinking here? Okay, so two different directions we can go here. Multiply the top equation by 3 will allow me to eliminate the y's. Okay, or multiply technically either of the equations by a negative, and that would eliminate the z's. As always, I'm going to say doesn't matter. No. Okay. I'll be honest, more people have been going the z route today than the y route. But again, it doesn't matter. So if I try and go with the majority, just for anyone watching, looking at the notes or watching the video, then I would say eliminate z's. Again, I'm so not against the y's. That's fine too. Okay. So if I do that, multiply one of them by a negative. If I multiply my top by a negative, let's look at what we end up with. So my equation is going to become positive 3z plus y equals negative 14. My bottom equation is going to stay negative 3z plus 3y equals 18. Three z's have a positive 3 and a negative 3, so I'm ready to add these. 3z plus negative 3z cancels. Y plus 3y is 4y. Negative 14 plus 18? 4. If 4y equals 4, divide by 4, and y is 1. Okay, hard part is done. Once you know a variable, what do I do with this y equals 1? Plug it in? Where do you guys want to plug it in? You don't.
4 or 5.
Yeah, and it has to be 4 or 5 this time, doesn't it? Last time I happened to have more options the way it worked out. This time, it's 4 or 5. What's your guys' pick? You used 5? I think I've used both today, honestly. So if we use 5, it's negative 3. Whoops. Negative 3z plus 3y equals 18. So negative 3z plus 3 times 1 equals 18. Negative 3z plus 3 equals 18. So if it's plus 3, we're going to subtract 3. Negative 3z equals 15. Divide by negative 3, and z is negative 5. I have y, I have z. Plug into something using x. So at this point, you have to go back to 1, 2, or 3. I don't know about you guys, but I like number 3. Even better yet, I like the solved version of number 3. Did you see that one? So I would use the x equals negative 2z minus 8 version. So x equals negative 2 times negative 5 minus 8. Negative 2 times negative 5 is 10, and 10 minus 8 is 2. Final answer? Whoops. Order triple, 2, 1, negative 5. Okay. On the back side, you do have one word problem example in homework. So on the back side, we don't have to solve it. My previous 2 classes today, I ran out of time. Your class, I might have time, but we won't solve it. We'll just be done. But I want to practice setting up the equations. Based on what I've been teaching today, we're going to be needing to set up not just 2, but 3 equations, right? So let's look at this example so you can get an idea for it. And then we can stop there. You manage a clothing store and budget $6,000 to restock 200 shirts. You can buy t-shirts for, that says $12 each, polo shirts for $24 each, and rugby shirts for $36 each. If you want to have twice as many rugby shirts as polo shirts, how many of each shirt do you buy? What do I need variables for? Let's start there.
Rugby shirts, polo shirts, t-shirts.
Yeah, it's how many of each shirt do you buy? Well, of our type of shirts, there were t-shirts. You can call this X, or I'm calling it T. You can call it any letter you want, right? There were polo shirts, which I'm going to call polo shirts P, and there were rugby shirts. Guess what? I'm calling that R. The other thing I want to point out to you here, Go back to that first sentence. There's some important information to help with the equations. You manage a clothing store and budget $6,000 to restock 200 shirts. Those two pieces of information are going to help us set up two of my three equations. Because one of my equations has to equal $6,000. And another equation has to equal 200 shirts. So again, remember we're doing three equations. 1, 2, 3. If we think about this first one and $6,000, what do you know about t-shirts? How many t-shirts are we getting? 200 t-shirts?
Oh, no.
200 shirts. How many t-shirts are we getting? Okay, t-shirts. We don't know, right? What do you know about the cost of each t-shirt? They're $12. So how can I express that in an equation where we're talking money? 12t, because it's $12 per shirt. I don't know how many shirts. Plus, what do you know about polo shirts? They're $24 each. We don't know how many we're getting, so we're going to say 24p. What do we know about rugby shirts? So 36 plus 36p, $36 each. P shirt, not P, 36R. My apologies there. And then it equals 6,000. I love my whiteout tape when I'm doing notes because I can immediately write over it. I learned several years ago that the bottle of whiteout does not work because I can't write over it right away. Okay. So one equation is equaling the 6,000. Now I need an equation that equals the 200 shirts. So how am I going to write an equation that equals the 200 shirts? What is it that has to equal 200? The number of shirts. Yeah, so your three variables added up. The t-shirts plus the polo shirts plus the rugby shirts. So T plus P plus R equals 200. And finally, go down to that last sentence for our third equation. If you want to have twice as many rugby shirts as polo shirts, how many of each shirt do you buy? Twice as many rugby shirts as polo shirts. So which one do I want more of? Twice as many rugby shirts. So more rugby shirts, right? Less polo shirts. So if I want more rugby shirts, I'm going to have to take the number of polo shirts and multiply it by 2. So the equation I'm going to write is R equals 2P. Because rugby is the bigger one, the one we want more of, we're going to say R equals, and to get that rugby, it's 2 times the lesser polo shirts. Now, unless you guys are just really motivated and want to, we don't have to solve it. But do you see how this one's set up to solve already? You already have R equals 2P. What am I going to do with that R equals 2P? Yeah, every place you see an R, you're going to replace it with 2P. And then you can clean up those equations and you'll be able to work with that. Is that okay? Okay. Give it a try. I'm sure we're going to be doing some more cleanup tomorrow. So, give them a try, see what you can do with them. We'll talk about them tomorrow.